Hey, Jasper. So today we are going to get started on an entirely different topic, and hopefully you guys are excited for it because it's going to be about the Raspberry Pi. So we're going to be going over an entirely different thing from all of the Inkscape we've been doing, and we're going to go more into the world of coding and computers and such, which is something that I'm personally very excited about. So, you know, your mileage may vary, but hopefully a little bit of my enthusiasm will bleed into this. So kind of like that. Yes, thank you, Jasper. But yeah, so we're going to acquaint ourselves with the Raspberry Pi today. We're going to spend some time getting it set up. I imagine that a lot of you have probably had some experience getting it set up. If not, that's okay. It's not very complicated, so I can't imagine we're going to take the whole class, but we might. We might take the whole class going through this first presentation. That's okay. If that's the case, we will save the actual getting introduced to Python for next Monday with Mr. Dubik. Otherwise, we'll get started on Python today. And we're going to get started on Python. We're going to familiarize ourselves with Python with CodeCombat. So, have you heard of it before? Chances are you guys have probably heard of it before. A lot of times, my middle school students, when I say like, "Oh, CodeCombat," they're like, "Oh, hey, yeah, I know what that is." Okay. Um, but if not, well, then maybe you're in for a pleasant surprise. Who knows? We'll see. But yeah, so we'll get the Raspberry Pi set up today, and then we will see where it goes from there. How's everybody's week been, by the way? Good, good. I'm glad to hear that. Well, hopefully you all have been doing interesting things and been enjoying your week so far. Good. I'm glad to hear it. So meet the Raspberry Pi. It is simply the single circuit board. The Raspberry Pi is a fully functional $39 microcomputer. You heard that right. It's a $39 computer. It's fully functional. It also has GPIO pins that can control motors, lights, and sounds or sense buttons, switches, or other environment. That's a weird comma. And sound or sense buttons, switches, and other environmental factors. So, does anybody know what GPIO stands for? Just as a, if you don't, that's totally fine. But just to get a feel for it. You have a breadboard for your Pi? Nice. General something, input something. Yeah, basically. Hey, 2 out of 4 ain't bad. It's general purpose input output. Um, General purpose. So GPIO pins are simply pins that you can set up to plug into other electronics. Um, Generated pins in option. Yeah, when they were making the Raspberry Pi, they went into the options and it said generate pins, and they went, yeah, sure. And so that's where GPIO comes from. Um, no, so general purpose input and output. The reason why they're called general purpose input and output is because they all, with a couple of exceptions, your mouse broke, so slow everything. Oh yeah. Oh, gotcha. So working is going to be a little bit slower. I get you. Well, that's okay. A lot of this is going to be sort of a luxury based thing, at least at first. So there's that. Uh, yeah, that's not so great. Um, so yeah, Raspberry Pi is a fully functional $39 microcomputer. It has GPIO pins that can control motors, lights, and sounds, or sense buttons, switches, and other environmental factors. GPIO, general purpose input output, with a couple of exceptions, tends to send out the same voltage on all of the pins. They also have the ability to receive voltage on all of those same pins, again, with a few exceptions. This means that you can customize. Oh, nice. Glad to hear it. This means that you can customize your pins to suit your needs. So you can have, like it says here, you can have a motor plugged into your Raspberry Pi, and then you can program your Raspberry Pi to run that motor at specific intervals. Um, you know, to control the motor to do certain things that you need, whatever that may be. You can hook up some LEDs to those pins. You can unplug the LEDs from those pins and then plug in a button. And then anytime the button is pressed, it will send a signal to the Raspberry Pi. That sort of thing. They're switchable. And so in that sense, you can actually hook up a whole circuit to your Raspberry Pi, and then you can use your Raspberry Pi as the brain of that circuit. Maybe you, let's see here. Maybe you set up an RFID receiver on one of the pins, or heck, you just plug your Raspberry Pi into your wireless or your Wi-Fi network. Since you got threes, you can hook your Raspberry Pi up wirelessly, and then you hook up on one of the GPIO pins a servo that's connected to a deadbolt on the door, and then you write something that takes some input from the internet, and then you create and install an app on your phone that allows you to, as long as you're in the we can go over that later. As long as you're in the your home Wi-Fi, nice. As long as you're in your home Wi-Fi, you can lock and unlock your door using your phone. Just a single idea. The GPIO pins allow you to really do anything you'd like. And the Raspberry Pi itself uses a Linux operating system called Raspbian, which is based on Debian. I was thinking it was GNOME last week. I was wrong. So yeah, this graphic from Element 14 shows the components that make up the Raspberry Pi 3. And there's a lot of them on there, but we're going to go through each of them in order. Yeah, just about all of them. So first you've got the Broadcom BCM 2837 64-bit quad-core CPU at 1.2 gigahertz and 1 gigabyte of RAM. Broadcom is the chip maker. These chips are mainly used in the cell phone and tablet market. So it's a very low-power chip, literally, as in it uses not that much electricity. You'll also see that 1.2 gigahertz is not exactly a blazingly fast computer speed, and you'll feel that when you start booting up the Raspberry Pi and trying to do things with it. You'll go like, oh my God, I just wanted to go faster. And that's okay. It goes fast enough for our purposes. It'll go much faster when you're running it on the command line. And for a lot of simple tasks and things like that, it's more than enough power. If you wanted to hook it up and have it be like a Nintendo emulator, not that I necessarily legally recommend that, you could. It'd be powerful enough for that. It's 0.5 gigahertz. Then you've got the 40-pin extended general purpose input-output. Oh, you already have? Oh, see, there you go. So you know that it's powerful enough. Yeah, it is. It's a $39 computer. I mean, it's gonna have. It's pretty amazing, in fact, that it's got 1.2 gigahertz and 1 gig of RAM on a $39 computer, though. For Atari mainly, yeah, I get you. Then you've got the USB ports. It's got 4 of them. Your laptop is 50. It's also got a LAN port. And I don't know. Yeah, okay, so it's listed over here. So we'll get to that in a second. But yeah, it's got a LAN port for network connections. It's also got modern audio/video capability. So it's got a 3.5 millimeter jack, and it's also got an HDMI output. Now the HDMI is generally just going to be video. However, HDMI itself is an audio and video protocol. So, you know, I haven't tested it. It might actually be possible to send sound out through the HDMI on the Raspberry Pi, but I'm not making any promises here, so I'm not going to say one way or the other. But it does have a 3.5 millimeter for like external speakers or something like that as well. It's got micro USB power input. It can handle up to 2.5 amps, but it's a 5-volt cell phone charger. So if you've got a phone charger for like an Android phone or something like that, you can use that to keep this Raspberry Pi powered. It requires very little power. The Pi operating system is installed on a micro SD card, and we insert the SD card underneath the Pi. And the SD card must be at least 8 gigs, and it must be at least 8 gigs so that it can hold the operating system and the bootloader and everything like that. But it can be larger, and that's okay. And the reason why they're micro SD cards is mainly for flexibility and things like that, and the ability to just sort of micro SD is super lightweight. So obviously you're not seeing like a platter drive on here. You don't have to worry about um, like flash memory or solid state or anything like that. HDMI to VGA, VGA to HDMI. Nice. Um, you don't have to worry about like more moving parts on the Pi itself or anything like that. Like literally, you just plug in that micro SD card, and you have. Yeah, I do. But not the one that I'm using right now. But I have one in my bedroom. Um, you plug in the micro SD and you have storage and a hard drive for your essentially it acts as a hard drive for your Raspberry Pi. One of the other advantages of that is that you can swap those out really easily. So let's say you have 2 or 3 different micro SD cards and they might be running different flavors of Raspbian. They might have different things installed on them. They might have different, cron jobs set up on each one of them. And so you can swap those out and thus swap out the purpose of your Raspberry Pi. Yeah, exactly, Jasper. Yeah, and yeah, Caveman. like chocolate, like chocolate. Then it's got onboard Bluetooth and Wi-Fi, so that's pretty awesome. So you can use Bluetooth to communicate with anything that has a Bluetooth receiver on it, and Wi-Fi in order to have it connected to your home network. So you got your Raspberry Pi, then you got your micro SD card, which contains your operating system. You got your 5-volt power supply. You got your HDMI cable. And you got your keyboard and mouse, and presumably a monitor as well. And these are the things that you're going to need in order to have basically a Raspberry Pi running like a full-on computer. So it's at this point, if you haven't gotten your Raspberry Pi set up yet, like if you haven't tried getting it hooked up to all the stuff, why don't you try and grab all that stuff now so that we can get it hooked up right now, so that you know exactly how to get a Raspberry Pi set up. Raise your hand if you're actually planning on doing that. Okay, so we got a few hands. All right, I'm gonna put your hands down, and then once you've gotten all the necessary supplies, go ahead and raise your hand again, or if you're ready to move on to the next slide. Basically, let's just say if you're ready to move on to the next slide and get started, go ahead and put your hand up again. And once we've got all the hands up, then we'll move forward. No mouse or keyboard. Okay, that's fair. Well, then just don't worry about it right now until you have a mouse and keyboard. And you'll understand why in a couple of minutes here. Yeah, just tomorrow or something like that, just go ahead and get it set up on your own time so that you know exactly how to do it. Nice. Yeah, it is pretty useful. I'm just waiting on just like 1 or 2 more hands. So once again, if you're ready to go on to the next slide, just go ahead and raise your hand. And okay, that looks like well, one day it really depends. They rely on local courier services for that kind of a thing, and the quality can vary incredibly widely as opposed to using big national delivery services like FedEx or UPS or something like that. Um, I know I ordered 1 day shipping on something and it didn't actually arrive for, I think it was 3, it might have been 4 days. And that's just because the local courier service really not that good. So 1 day is better in theory. However, if you want consistency, go for the 2 day. And if you have Amazon Prime, it's free. So, you know, that's awesome. Anyway, now that I'm done being an advertisement for Amazon, let's move on. So the first thing we're going to do is we're going to insert the micro SD card. I don't know why this is listed twice. Boom, micro SD card into the Raspberry Pi. So if you look on the bottom of the Raspberry Pi, you will see a slot for that micro SD card. We don't really have a picture of the bottom of the Raspberry Pi on this presentation, unfortunately. Um, would a laptop work for a Raspberry Pi? Okay, so this is an interesting question, and this sort of brings into question the nature of the Raspberry Pi. Depends on what you're looking to use the laptop for, because laptops generally really only take in other forms of inputs. That is to say, the output that you can really only send out on the laptop is network traffic and video data, to maybe have like a second monitor or something like that. But it's not like you can plug in like the laptop's keyboard to another thing and control it with the keyboard or the trackpad or the mouse or whatever. Obviously, your mileage may vary depending upon the laptop and stuff like that. So the question, the way you're asking it, it sort of becomes would a laptop work for controlling my computer? Um, and that's not meant to be like, oh, hey, why'd you ask that? Because it's a perfectly legitimate question. But it's better to think of the Raspberry Pi like its own computer. If you want to get like a desktop computer up and running, you want to make sure you've got, you know, a monitor uh, and in this case, a TV can work for that. But you want to make sure you have some sort of display. You want to make sure you have the connector, which is going to be the HDMI cable. You want to make sure that you have control peripherals like a mouse or a keyboard, and definitely want to make sure that you have like your power and stuff like that. So in this sense, a laptop isn't really going to work, not yet at least. Now, down the line, you can set up your Raspberry Pi to be always plugged in and connected to your network, but not connected to like HDMI or USB or anything like that, sort of looking headless. However, you could then get on your laptop, get on the network, and either SSH or remote desktop into your Raspberry Pi and control it there. So that would certainly be a possibility. But as it stands, there's some initial setup that needs to be done. So um, right now, unfortunately, no. Does that make sense? Cool. All right. Just want to make sure. All right, so yeah, step one is inserting the micro SD card into the Raspberry Pi. If you guys can't do this stuff right now, though, because you're missing something, that's totally fine. Just follow along with the process, and then at least get your Raspberry Pi set up once before Monday so you know what you're in store for. You're not necessarily going to have to use it on Monday, but just so you have a familiarity with the process, and in case we end up using it on Monday, then you can just plug everything in and have it be good to go. So we've plugged in our hard drive. Now we're going to plug the keyboard and mouse into the USB ports. Pretty straightforward. I mean, this whole process is pretty simple, but there is at least somewhat of an order to it. So yeah, plug the keyboard and mouse into the USB ports. Then you're going to plug the HDMI cable into the HDMI port, and you want to be sure that the monitor is on. You definitely want to be sure that the monitor is on. And we're going to get to that point, why you want to make sure the monitor is on, in just a minute. Once you've plugged everything in, finally you're going to plug in the 5-volt power source. Finally. So you might be going like, okay, so why did we plug in the power last? And why do we have to make sure that the monitor is on? Or you might not be, and you're just a hypothetical student that I made up so that I can answer this question for you guys so that now you know now. But I'm going to do it anyway. So the reason why we plug in the power last and why we want the monitor on is one of the things that the Raspberry Pi is very good at being is modular, is flexible, is adaptable. You can use the Raspberry Pi as a small file server. You can use the Raspberry Pi as your magical door unlocker. You can use the Raspberry Pi as a retro game system. You can use the Raspberry Pi as a regular, computer for hobby coding and play and stuff like that. You can use the Raspberry Pi to, uh, I don't know, uh, insert small project here. Um, the advantage of that is that the Raspberry Pi is very good at adapting to its given situation and adjusting its power draw based on that. Because it also wants to make sure, yeah, there you go. It also wants to make sure that it draws as little power as possible. Draws and uses as little power as possible. So one of the things it does is well, there are two things it does. As soon as you plug it in, it starts to boot up immediately. There's no power button, no nothing. They didn't waste time with that kind of stuff because they assumed that as long as you have it plugged in, you want it to, you want it to be running and you want it to be doing the thing that it does. And then the second thing it does is as soon as it's plugged in and it starts going through its boot process, it basically queries all of the plugs on it to see what in fact is plugged in, because keyboards and mice will send back signals like, "Hey, I'm here." So will monitors, provided they're on and stuff like that. And if it gets something back saying, "Hey, I'm here," then it's going to activate that plug as long as it's on. So then you can unplug the monitor after it's been on and booted up and it has the monitor, and then you can come back a little bit later and plug the monitor back in. It'll still be sending information out through the data port, or excuse me, the video port, and you'll be able to see things and blah blah blah. However, if you boot it up without a monitor plugged into the HDMI port or with the monitor or TV off, it's not going to send a signal back saying, "Hey, I'm here," and the Raspberry Pi is going to go, "Hey, okay, so like there's nothing plugged in there. They probably want us to run headless, so we're going to we're not going to send anything out through the video port, and it won't try again until it reboots." So that's the thing. If you boot it up and you go like, "Hey, I don't have any display," or "Oh, it's not accepting input from the keyboard," or something like that, you gotta unfortunately make sure that it's plugged in. Well, this is not the unfortunate part. You gotta make sure it's plugged in. And if it wasn't plugged in, unfortunately, you've got to unplug the Raspberry Pi, then plug in the thing that you want to plug in. Just the power. You don't have to unplug any other peripherals or anything like that. You just have to make sure you unplug the power, then plug in the thing that was accidentally unplugged, and then plug the Raspberry Pi back into the power. And then it will go through the boot process again. It will detect that your thing is there, and everything will be, word hunky-dory, or maybe neato. Um, yeah, I shoehorned that one in a little bit. uh, but yeah, yeah, so that's an important note about the Raspberry Pi. Chances are your Raspberry Pi is not broken. It's just not aware that there's something plugged in there, or aware that there should be something plugged in there, and so it's going to pretend that it ain't, and it never will be. There's also this is the sabotage game is a thing that we do in like the labs and stuff like that during the summer. Basically, all it involves is you kind of do like a musical chair thing. Oh, it's super cool. You kind of do a musical chairs thing, and you get somebody else's Raspberry Pi, and you unplug the Raspberry Pi, and then do something like you unplug the keyboard, or you unplug the actual power source from the wall, or whatever the case may be. But you make it so that the person has to figure out why their Raspberry Pi isn't working. What does a 5-volt power source look like? 5-volt power source is just a phone charger. So if you've got like an Android phone or a Kindle, um, or some other small electronic device, uh, chances are it runs off of a 5-volt wall charger, and that wall charger will be enough to keep the Raspberry Pi powered. Not iPhones, no. Well, okay, so here's the deal. That is, if memory serves correctly, that's 5 volts. However, the connection on it is not a micro USB. Yeah, and that is the rub. All right. So, if you were looking to get your Raspberry Pi up and running today, and you did attempt it along with me, raise your hand if your Raspberry Pi is booting up. Cool. All right, raise your hand if you're just following along, but you're not actually going to attempt plugging in your Raspberry Pi today. Alrighty, and finally, raise your hand if you're still getting your Raspberry Pi plugged in. Not judging, just want to know where everybody's standing in the situation. Oh, you do. Okay, cool. So we got a couple of people still working on it. No worries. We'll chill out for a minute or two and just sort of hang out. Mm. Dog. Chill out, dog. You got one for Christmas. Nice. That's a pretty cool gift for Christmas. I would have been pretty stoked, but I mean, that's because I like, you know, getting things that I can theoretically break. Oh, with a kit, gotcha. Woof dog. Woof dog. Nothing came in. Don't sweat it. Come on, what? I want to make sure everybody's on the same page. This is important. You're not the only one in the class. All right. Raise your hand if you were hooking up your Raspberry Pi, but you're good to go now. All right, well, that's just about everybody. If we have, if you're still working on it, that's cool. No worries. Um, you can always, we can always go over it at the end of class as well. Like reserve a few minutes at like 7:50 or something like that in case you run into a question. The computer HDMI plug can't reach the desktop. Ew, that's not great. Uh, that's annoying. Well, do you understand the process at least? Okay. Well, this video will go up on YouTube either like right after my next class or tomorrow afternoon, depending upon how long it takes the videos to render. So well, I say right after. Um, it's like 11 o'clock midnight or sometime tomorrow afternoon, depending upon how long it takes for these videos to render. But uh, we'll reserve some time for questions at the end, and you can always go over the video on YouTube to get a feel for the process again. So, when you, for sure, when you first boot up your Raspberry Pi, after it goes through the bootloader and everything like that, and it boots up the GUI and blah blah blah, you're gonna get the home screen, and it's gonna look something like this. You're gonna have your sort of taskbar along the top. You're gonna have your desktop down here. You're gonna have a few other things. Anyway, you're gonna wanna. Oh, there's a new one now. Yeah, these are a bit of outdated slideshows, and I do not yet own a 3, so unfortunately, I cannot show off all the neato things about the 3's latest build of Raspbian. Actually, I should just download the latest build of Raspbian for my 2B, but oh man, I have to get it plugged in because it doesn't run on Wi-Fi. And it worked so much better in my last place when I could just run a network cable around the wall instead of through 3 rooms. Anyway, so yeah, you're going to click on menu to access applications. Yeah, but I need to get hooked up to this network. It's a totally different network, which means I need to get it plugged in a different location, and it's going to be a pain in the booty. All right, so click on menu to access applications. You've got a whole bunch of different minor programming applications, Office applications, internet, so email, web browser, and Raspberry Pi resources, games. At least the older versions of Raspbian came with Minecraft Pi and Python games. Accessories, just your basic operating system accessories, calculator, file manager, so on and so forth. And then you've got Raspberry Pi help and Debian help. Then you've also got basic operating system things as well, like add, remove software, and change the appearance, and mouse and keyboard settings, and configure your Raspberry Pi. Nice. Then you've got quick access. Well, okay, again, this is an outdated one. Internet, file management, which is the Explorer, terminal, Mathematica, and Wolfram. And in case you're not really sure what those are, what's the question mark about? Oh, Wolfram? Yeah, we'll get there. We'll get there. Then you've also got access to the Bluetooth, wireless, sound, and the percent of CPU usage, and the time, and eject the SD card. Well, we're not going to spend too much time. Okay, so here we go. So Wolfram. Mathematica and Wolfram is technical computing. Basically, it's like Google, but for math equations. So if I go to wolframalpha.com, hey, look at that. Like you enter what you want to calculate or know about, and I can say the total GDP of US divided by surface area of Earth, and hit enter. And even though these are not really two comparable things, they don't really make any sense. It'll crunch the numbers on them. So input interpretation, Earth surface area, square miles, okay. US GDP. There we go. Let's try that again. We'll wait for it to load. It's still not getting it. For some reason, it's not interpreting US GDP. So not exactly a strong showing out of the gate for Wolfram, but it's actually a very useful program. So as you can see here, the result of the surface area of the Earth is 200 million square miles in this database. Unit conversions: 5.5 times 10 to the 15 square feet, 5.1 times 10 to the 8 square kilometers, 5.1 times 10 to the 14 square meters. Compares this as an area. It's the surface area of the entire Earth is 1.5 times the area of ocean on the Earth. So that is to say, the ocean is about 2/3 of the Earth's surface, if I'm doing the math in my head correctly. It's 17 times, roughly 17 times the area of land ruled by the Mongol Empire at its peak. So Mongolia was about 1/17th of the entire surface of the Earth at its peak, which is pretty impressive considering the time and everything. And then it shows you how it gets the calculations, if it does in fact do some calculations. Assuming Earth is a planet, uses a geographic region or all countries instead. But yeah, so that's Wolfram Alpha for you. You can say, area bounded under a parabola defined by y equals x squared plus 15x. Just a simple. And then it'll give you some plots and give you derivatives and everything like that. Huh. It's a very useful tool, especially if you start getting more into mathematical calculations and things like that. You can refer to it for help with problems and stuff like that. Anyway, that's Wolfram. And then Mathematica is the notebook interface that uses Wolfram, and then Wolfram is the command line interface. So these two are sort of two different flavors of that Wolfram Alpha engine. There's the command line in order to get results, and then there's the notebook, which allows you to, wait, I have those backwards. Notebook and command line. 3.14159. For that many digits, yes. So yeah, there's a whole lot of programming software available on the Pi. We're going to be utilizing, I believe, Python 3 now. I believe Python 3 is mature enough at this point and developed enough at this point that we can start working on it as a language. Because for a while 2 was definitely the go-to and 3 wasn't really utilized enough yet, but I don't think that's the case anymore. Learn programming by making music with Sonic Pi. And then Raspberry Pi uses a special version of Scratch, which is similar to Scratch 1.4. So, I'm sure you guys have had some familiarity with Scratch as well. Raspberry Pi does have Scratch. Nice. I'm not even going to fact check that because that's 5 minutes. Yeah, well, I just don't want to doubt you in this situation. And then also it would take a while. Raspberry Pi Scratch and Scratch 2.0. So the Raspberry Pi Scratch is a little bit outdated, but insofar as it doesn't have quite as many features as 2.0, but 2.0 is fairly nice anyway, and Raspberry Pi Scratch is perfect for a lot of the stuff that we'd be looking to do anyway. So yeah, that's a quick run through of that. I'm hoping by next Wednesday I'll have a Raspberry Pi hooked up on my network so that I can actually like go along on these things with you guys, provided that we're working on the Raspberry Pi by then, because we might actually just be doing CodeCombat. So let's see here. Let me go ahead and get the appropriate one opened up. So this is lesson 1, boom. So show of hands, who here is familiar with CodeCombat? Couple of hands. Not many, but a couple of hands. All right. That's a little bit surprising. I was expecting more hands. But that's okay. So CodeCombat is a game. CodeCombat, its intention is to teach you real line-based code, as opposed to Scratch, which is like, dragging and dropping blocks and things like that. This is sort of like a step up from Scratch, I suppose, because now you're learning syntax and things. So this coding in CodeCombat involves using the actual programming languages. When we say it's a Python CodeCombat, we're going to be programming in Python. It's not going to be like an approximation of Python. All right, some song lyrics. All right, so challenging puzzle and battle-based levels teach you and test you on different programming fundamentals from variables to functions. The code you're writing uses real syntax, meaning the lines you write to solve these puzzles are real lines of code. Like I was just saying, I think we've already established that. So we're going to navigate to codecombat.com and set ourselves up an account. And I think that's about as far as we're going to get today. Because then you can actually launch into like the using CodeCombat and stuff like that with a fresh mind after the weekend on Monday and everything. So codecombat.com. And we're just going to click Create Accounts. And by the way, those of you who are running this at home, handy little tip, you can hit Control T in order to open up a new tab in whatever browser you're on. Just in case, say for instance, you don't have a working mouse. No, you're going to sign up. So you're not going to choose student. You're going to sign up as an individual. Then you're going to enter in your birth date here. Let's just say 2003, just to see. Boom. And then you create an individual account, email address, username, and password. And then when you're done, click Create Account. I believe it will ask if you're 13 and under. I believe it will ask for. Well, let's just test it. Boom. Let's say 2005, which would put you at 11, turning 12. Enter your parents' email address. Yeah, so you'd enter your parents' email address. Your parents would receive an email asking if it's okay for you to sign up. They would click on it, and then you guys would go through the process of creating an account. And that's only if you're younger than 13, I believe. So if we set it up to be, let's see here, 2004, which would put you at 12, parents' email address, 2003, which would put you at 13, turning 14, you're okay. Yeah, so if you're 13, you're okay. If you're younger than 13, you need a parent's permission, or don't tell anybody I said this. You can also just put in a slightly older age. Because ultimately that call is yours and your parents to make. I'm not going to say one way or the other. If you don't feel comfortable doing that, obviously don't do it. But um, if you're, and far be it from me to suggest that anybody should, yeah, I figured as much. That's the thing. I also don't want to be blind to the fact that this is probably a thing you guys do on a fairly regular basis. Yeah, so do whatever you got to do in order to get an account set up, and then once you've got an account set up, we're gonna call it a day there. So we're gonna say that that's the last thing we do today, which gives us some time to do poll questions and then question and answer time. All right, so let me go ahead and get the poll questions started. Once I've gotten those both the questions out and you guys have answered them, we'll leave it open for question and answer time. Once we get to question and answer time, if you guys don't have any questions, you are by no means required to stay here. You're more than welcome to head on out. Gotcha. You're more than welcome to head on out and, you know, have a wonderful rest of your week and have a wonderful weekend and everything like that. Once we've done the poll questions. But other than that, just I ask that you stick around for that. So here we go. First poll question incoming.